Hello everyone. In this video, we will be learning how we can implement Heap. In my previous video, I have explained what is Heap, what are the types of Heap, and what is the application of Heap. Now, we know that there are two types of Heap. One is max heap and another one is min heap. Okay. So suppose I will be drawing a min heap. So suppose this is the min heap, and we know that heap is a complete binary tree, and in case of min heap each node will have the value smaller as compared to its descendant values. Okay, so this is a min heap. Now in order to represent this min heap, the data structure which we are going to use is array. So we can use array to represent min heap. Okay, so basically this is a min heap and we need to make it fit in a array data structure. So in tree we know that there is a parent and there is a left child and the right child. Okay, now if we are representing this min heap in array, we need to find some relations, like how we can have the relation between parent and left child or parent and right child. So basically what we can do is that we can assign each node an index value. Okay, so this is the root node will have index 0, this will have index 1, this will have index 2, 3 and 4. Now it's very easy to store each value corresponding to its index value in array. So I'll be making a array, and this is the index value 0, index 0, 1, 2, 3 and 4. So in index 0 the value is 1. Index 1 the value is 2. In index 2 the value is 3. Index 3 the value is 4, and in index 4 the value is 5. So we have converted the tree representation of min heap in array. Now we need to find out the relationship between parent and left and right child. So suppose in this tree, if I am having the value, that is the root value 1, this is the parent value. So the left child node is the node having value 2, and the right child node is the node having value 3. So the index of this node is 0, and index of this node is 1, index of this node is 2. So if we observe this, we find that if the parent value is I, that is the index value, the left child value will be 2i plus 1, and the right child value will be 2i plus 2. So basically you can take any example from this min heap. After taking 2 to 3 examples, it will be observed that the relation between parent left child and parent right child is 2i plus 1 and 2i plus 2. Okay, now we are going to apply this in array. So suppose I am having the node value 2. Okay, so this is the node value 2 and its index number is 1. I need to find what will be the left and the right child. Okay, so what will be the value in the left child and in the right child? So this is I. The left child formula is 2i plus 1, which is 2 into 1 plus 1, which is 3. So value at index 3 will be the left child. Okay, value at index 3 will be the left child, which is 4. Now the right child value is 2I plus 2. So 2 into 1 plus 2 is 4. So value at index 4 will be the right child. Okay. So this is 2 and value at index 3 is the left child. So what is the value at index 3? It's 4. Value at index 4 is the right child. So what is the value at index 4? Is 5. So basically if we are having this as a parent, 4 and 5 will be its left and right child respectively. So if I check in this tree diagram, we find that on having 2 as a parent, 4 and 5 is the left and right child. Okay, so this is the relation which we can use. Like if we are having an array and we have been told that this array is following min heap or max heap property, using this parent left child and right child relation, we can assume or we can find what will be the left right child and the right child of corresponding parent index. Okay, so similarly if I'm having the parent value as 4, if I'm having the parent value as the 4, so left child will be 2I plus 1. What is the index of this 4? The index of this 4 is 3. So 2I plus 1 means go to index value 7. But in index value 7, there is no value present over there because the maximum size or the maximum capacity is 4 till index 4. So basically there won't be any left child. Similarly, there is no right child. Okay. So basically the 4 will be the leaf node having no left and no right child. Okay. Now suppose this is the thing which we can use for finding the parent and the left child and the right child. Now I need to find the parent node. Okay, now I need to find the parent node. So for finding the parent, the formula which we can use is the floor of I minus 1 by 2. Okay, now suppose this is the node value and the parent of this node is what? The parent of this node is 1. Now in terms of index, the value 3 is at index 2 minus 1 by 2. So it's basically 0.5 and the floor value of 0.5 is 0. So the value at index 0 is the parent node. Okay. The value at index 0 is the parent node. So represent heap, in order to represent heap, array data structure is useful. Okay, and will be having size and will be having capacity as its attribute, and there can be a constructor, and the role of the constructor is to initialize the object. So it will be initializing, like it will be creating an array of size n, it will be assigning size value to 0 and capacity to n. Okay, and the most important thing is the relation that we got. So suppose in order to find the left child, this is the left child, we will be having index I, the formula is 2I plus 1. In order to find the right child, we'll be having index, the formula is 2I plus 2. And for parent, if we are having index, the formula will be I minus 1 by 2 floor. Okay, so in array, if we got an array, we can easily use these relations to get the parent child value. So this is all about heap implementation.